So my name is Nand. Thanks for the introduction. I'm a research engineer at Clarifai, and I'm here today to talk about how you can integrate Clarifai's powerful machine learning APIs into your applications. So the outline for my talk is going to go something like this. I'll go over a brief history of computer vision and how Clarifai kind of fits into that story. I'll go over our V1 set of APIs, and then I'll talk about our V2 set of APIs that we released recently in October. So the V1 set of APIs are about general and domain models, and then this V2 set of APIs mainly deal with custom training and visual search. So with that, let's get started. So people have been working on image recognition for a while now. Before neural nets, people relied on hand-engineered features and passing those to kind of shallow classifiers, which performed reasonably well. But recently, due to a confluence of things, we've gotten much better results. So people have been able to start applying neural nets, mainly developed by Jeff Hinton and Yann LeCun in the 1980s. So this is not like a new idea. This is just a resurgence of an algorithm that was developed a while back. And it's come back because of two main things, in my opinion. One is IoT. I think there's a lot of devices out there constantly collecting data, especially images and videos. We're constantly uploading images and videos to the internet. And advances in computing. So because of companies like NVIDIA and AMD, there's great GPUs which make it really easy to program neural nets and make them really fast so that we can process lots of data. So a classic kind of benchmark that people use to evaluate their image recognition systems is this challenge called ImageNet. And ImageNet is a challenge where you're given 1 million images over 1,000 set of classes. This can be images related to like dogs, cats, different breeds of dogs. So it's a very tough competition. And we can see before people started applying neural nets in like 2011, the error rate was around 25.7%. But when someone from UToronto decided to start applying neural nets to this problem, there was a step function of increase in accuracy. So the error rate went down from 25% down to 16%. And the following year, our CEO, Matt Zeeler, he submitted his solution to ImageNet and got even better accuracy, and that's when he founded Clarifai. And that's kind of how we got started. And since then, there's been lots of progress from like these bigger companies and some research labs, such as Microsoft and Google, on ImageNet. Someone actually took this challenge as a human. They got 5.1% error, but since then, we've been able to beat that benchmark. So the specific type of algorithm that we use for image recognition is convolutional neural nets. There's other kinds of neural nets like recurrent ones that are used for more continuous or time series type data like videos or text. But I'll go a little bit deeper into convolutional nets because that's what we use mainly for image recognition. So a neural net, a convolutional net, can be thought of as a cascade of filters or a cascade of weighted averages. So the important thing to note here is we're passing the image directly into our neural net without having to hand engineer any features. So we're just giving the raw RGB pixels to our model, and out pops probabilities. You can see on the right, boat, cat, bird, dog. And as we train this model for a lot of iterations over a lot of different kinds of data, we're able to get it to perform well and make good predictions. For example, predict boat when it sees boat in this image. Some interesting work, because this is kind of a black box algorithm, is to visualize what's actually going on inside the neural net. What exactly is the neural net learning as it's processing all this data? So some other interesting work that our CEO did was kind of visualize the different features from different layers in the neural network. So as I mentioned in the previous slide, there's different layers in the network, and this is showing the filters from the first layer. And what we see here are there's things like edge detectors. So you can see there's edge detectors, color filters, and this is kind of related to the hand-engineered features that people were developing prior to neural nets. So it is coming up with some kind of like good solutions in the initial layers. Then deeper into the network, we're getting more robust representations of the data. Here, I don't think you're able to see it from your seats, but you can come after the talk and look at my laptop. But there's tiny patches that look like the images that it was trained on. For example, tiny filters that look like dogs, cats, telephones, and you can visualize this here. So that's kind of how Clarifai got into this field of image and video recognition. And since then, we've been working on a variety of different models, what we call domain models, which specialize in specific domains. So for example, right now we have a general model which understands over 11,000 tags, but there might be specific domains like food, where there's specific things to understand like pepperoni on pizza or things like that, which our general model is not aware of. So that's why we have these domain models. And for that, I'm going to go for a quick demo to show you some of our domain models. So this is our model gallery. This is showcasing some of our domain models. The first one I'll show you is, as I mentioned, the food domain model. And the food domain model has gone, and we've trained this over a lot of different images of food with very specific ingredients, so that when you show this model an image, it can understand what kind of ingredients it has. So in here it has lemon, lime, seafood, or in this image, I'm vegetarian, so I like this picture a little bit better. This is a picture of a waffle, and we see that it has like syrup, waffle, French toast, so it's kind of gotten an understanding of what's in this image. We'll go back and show you one other domain model. This is a little bit different than image recognition. This is called image detection. So what we're doing here is detecting where certain objects are in the photo, and in this particular case, we're doing face detection. So here we're able to create bounding boxes over where the faces are in the image. So here we find these two faces. We can also handle different sizes of faces. So like, for example, that face is a little bit smaller, and we're able to still detect that. And our domain models are really easy to use. So here we see an example of using our general model. All you do is import, so this is the Python client. All you do is import Clarifai, authenticate with an ID and secret. You get a model, in this case the general model, and then predict using that model on a URL. You can also use an image from your hard drive or from a stream of images. In this case, we're just using a URL. So it's very simple to use our domain models. So that's great. But maybe the concepts in the general model and the domain models, like the food model, don't exactly apply to your specific application. Maybe you need to understand a specific set of concepts, or maybe you have a specific taxonomy that you need to understand. And with that in mind, we know that people have various different perspectives of the world. People view the world in different ways, and that's why we want people to be able to train neural networks to understand their own taxonomy of data. And that's why we developed custom training. This lets you teach our AI about your own concepts and your own taxonomy of data. It's much like teaching a child to see the world for the first time. So before I go into what custom training is, let me quickly go over how we create these domain models, or how you would go about creating a custom model on your own set of concepts. So first of all, you'd need lots of code. You'd need to use a library like Caffe, Theano, Torch, TensorFlow, and do a lot of coding in terms of reading in data, optimizing your neural net, training it, getting some serving infrastructure for serving your model, and that's a lot of tedious work. You need data scientists to do that work. You need special kinds of hardware. I mentioned GPUs are really nice for training these neural nets, but not everybody can just offhand have these $1,000 GPUs. And more specifically, you need tons of examples to feed your classifier. So that's really not feasible. Think of an application, maybe you're developing something for an iPhone or an Android phone, and your user just has a couple of images. They can't train a model with just a couple of images. You need thousands of examples. So how do we get, and it takes a ton of weeks. So for example, you might submit an experiment to train a model, and it might come back after a couple of weeks. Maybe it didn't really learn anything, and you have to try a whole new set of experiments. It takes months to train these neural nets. So how do we get everyone to be able to train AI really fast? So first of all, let's get rid of specialized hardware. We want to be able to run these algorithms anywhere. Let's kind of get rid of data scientists. We don't want to have to deal with data scientists. We want to be able to immediately get AI into our applications without having to hire someone. And let's make this work with just a few examples. That's really powerful because now you don't have to curate these large data sets. You can just use a few examples and start getting understanding out of your data. And let's make lots of code into the few lines of code that we saw before, importing, authenticating, and then using this, using your model. And let's make it go in seconds. So you can iterate quickly and create a bunch of models, figure out which one's the best one, and then deploy that in your production systems. So with that, I'd like to introduce custom training. And for that, we'll go to a demo. So what I'm going to do for the demo is kind of walk through a typical workflow that we expect users to use for training models using Clarifai. So what we've built is this nice, easy to use, very fun actually, UI. And with this UI, what we're able to do is quickly train a model using some images that we upload from our laptop or from wherever you want, and then have that model get it ready to deploy into production. So for this example, I want to kind of classify avocados versus guacamole. And what I'm going to do is first teach the neural network using a couple of examples of each, and then I'll evaluate it to see how well it did on some unseen examples. So first I'll upload some avocados. Boom. Now they processed. And I'll upload some guacamole. Yes. All right, so they're uploaded, and now they're in my application. And we can just click on one and see already that Clarifai has a kind of understanding of what's in this image. It knows that, okay, I actually didn't know that the general model knew about avocados and guacamole. But let's say it didn't. For example, this image. Yeah, it doesn't know that this is an avocado. So let's train the model using our own custom concepts to know that this is avocado versus guacamole. So what I'm going to do is select this image, add a concept, and say that this is an avocado. Avocado. Yes. All right. And I'm going to select these two images and say that they're guac. So I've quickly labeled some of our examples. And now I have a model, and the model has two concepts, the ones that I taught it about, avocado and guac, and I'll train my model. So the model is trained successfully, as it says on the right. So let's go back to the images and evaluate. So we're going to give it some unseen examples. So these two images on the bottom, if you remember, I didn't give it these two. So, or did I? Let me just check. Oh, I gave it the bottom two. We'll evaluate on the top two images. And for guac, we didn't give it these two examples. So let's evaluate. Yeah, so these are new images. And it has a pretty good understanding that this is avocado and this is not guacamole. Next one, yeah, immediately knows avocado, not guacamole, and then vice versa for this one. Or this one's a labeled example. Let's get one that's not labeled. Oops. Right, so this is guacamole and not avocado. And same with this one. So as you saw in this demo, there's just a couple of examples, like 2 or 3 per category, and we're immediately able to get a classifier that's generalized to unseen images, specifically like unseen images of guac and avocado. So that was kind of using the UI, but let's say you had like 1 million images that you wanted to train over. That's oftentimes like what, if you're collecting tons of data, maybe you want to use all of it to get a better understanding of your concepts. And to do that, you can use some kind of SDK that we provide. So this is using the Python client, and the same thing like tagging. It's just importing Clarifai, authenticating, instead of tagging, we're going to create 2 new images and tag them with our concepts, in this case, cute dog and cute cat. And then we're going to create a model with those 2 concepts, train it with 1 call, and then predict with it. So that's our entire workflow. We went from a whole system for developing a neural net to just 5 lines of code to quickly add images, train it, and predict with our model. So you might have seen a few things that happen in the UI to kind of quickly tag these images. And these are just some of the tricks that we're able to do to quickly tag a bunch of to quickly label a bunch of images while we're training our model. And this is part of another feature that we recently launched in parallel with custom training called AI-powered search. And there's a lot of ways to use search, and I'll go through a few of them right now. So first of all, Clarifai already knows about some of the concepts that are probably in your image via our general model, like concepts like dog, cat, and like kind of things that are very common. So Clarifai automatically understands these images and then applies the most relevant keywords to them, indexes them, and then when you want to go search for a dog out of maybe you have millions of images, you can just search in the toolbar dog or use one of our clients to do that, and it'll immediately come up with some dogs. So let's just see. This isn't live. This is kind of just some slides, but we'll go to a demo pretty soon. So we just searched dog, and we got a bunch of images of dogs out of our whole corpus of images. A more interesting use case is, let's say a user types in a really complicated query. In this case, a red laced up sneakers with weird embellishments. So I don't even know what that is. Much less the AI has no idea what this is actually. It doesn't know that it's an individual object. But what if our user had taken a picture of what they were interested in, and now they want to search using that image? So here they took a picture of some kind of shoe with embellishments on it, and our AI-powered search called visual search is automatically able to get images out of the corpus of images and surface that back to the user. And the thing to note here is that this isn't something like Google image search. This is searching over your own set of images. So if you have some images like thousands, 10,000s, millions, you can search over them using visual search. And the last most interesting kind of search, in my opinion, is combined search. So combined search is essentially taking multiple subqueries. So you could think of the concept search, which we did first, and then the visual search that we did second, and we want to combine these searches. So let's just see that in action. We want that visual search, and we want dog, and now we got dogs wearing those sneakers. So I think this is a really powerful tool in the sense that you're able to do a big and on all your subqueries and get a really powerful query that's tuned to what maybe your users want to understand or what your users want to surface from your database. So this is an app we already have. I'm not going to bother adding images. We already have a bunch of images of flowers here, and we have a trained model on just a couple of the images that I saw. I actually trained this right before the demo. So I just added one label of bee, one label of dandelion, lotus, and tulip. So we have some of the concepts in our model. Oh yeah, they're right here. Bee, dandelion, lotus, and tulip. So let's do an interesting query here. Let's click on bee. So what this is doing, it's not doing a tag search because I've only tagged one image as bee in my corpus of data. What this is doing is using the trained model that was trained on a bee, and now it has an understanding of what bee is, and now it's going to go over my whole corpus of data and pick out all the images that have bees in them without me having to actually tag them. So here we can keep scrolling, and we have all our bees from our entire corpus. I think there might be like 1 million images in here. And another interesting one, which is kind of like our combined search, which is just a fun one to see, is let's say we have these bluebonnets, and we have this red rose, and we want to see, so what would you expect a red rose and a bluebonnet to, and a search with an and between them to produce? So we have a red image, a blue image. What do you expect the and of those two to be? Any ideas? Purple. All right, let's see. So red, bluebonnet, and let's search with both of these and see what happens. It's thinking, and boom. We got purple-looking flowers in our search. So I think that's like just one interesting way that we're combining the visual features of our two query images and surfacing these kind of red, kind of blue, purple actually, images. And search is also similar to custom training and tagging, very easy to integrate into your applications, into your search bars. You just authenticate and search with a given image or search with a given tag, or yeah. So that kind of wraps up my talk. The key takeaways are that you can leverage the general and domain models from our V1 set of APIs to tag a bunch of images from a broad range of domains. And then maybe the images that you want to tag aren't really part of the understanding of our domain models. In that case, you can use custom training and visual search to personalize your AI by understanding your own taxonomy and searching over your own corpuses of data. And with that, I'd like to thank you, and also want to mention we are hiring. Yeah.
Thank you so much.
Thank you.